Good day, everyone. I am Ned Martinez, and we are going to report, or I am going to report about pumps, its definitions, and its parts. So, what is pump? Definition and functions of pumps. Pump is a mechanical device that uses to transfer different fluids from one location to another. It is a hydraulic device that lifts fluids from low to high levels or move fluids from low to high pressure areas. A pump just generates the necessary fluid flow to develop the pressure, which helps the pump transfer fluid from one location to another. It just produces the fluid flow. It doesn't produce pressure. So as it is self-explanatory that pump is serves as a it serves as a mediator to transfer one fluid from a particular location to another location. So it is self-explanatory. The main pump uses for pumping water, slurries, food, wastewater, oil, and gas. The pumps also used for irrigation systems, power plants, wastewater treatment systems, chemical industries, food industries, fertilizer industries, and etc. Ang pinaka-obvious siguro nato na ma-feel nga magamit ang pumps is sa ato mga household na mga tubig para kusog ang pressure sa ato tubig doon maabot sa ato balay kailangan ng pumps kay for example daan sa low area ang source ng water tapos i-distribute sa high level na subdivision so kailangan nyo din ng pumps para maabot itong water. Sa mo gud ng murag pinaka obvious nato nga makita ang example ng pump sa applications of pumps. Number one, these used to transmit water from one place to another place. So as I have said earlier na kibali nagkuha kag source na water from a lower level. So para mo adto ang water sa upper level kung asa nimo isend ang imuhang water, kailangan jud kag pumps. Amo din ang usa ka application. They use for fuel injection in different vehicles. So para sa mga motor ko man na fuel injection na para paspas na ang pag-transfer ng fuel gikan sa chamber pasingod sa padulong sa engine. Uses for cooling water purposes sa mga cooling water sub. For pumping gas or oil, jay siguro naipod sa kanang mga gasoline station, syempre kay imo man i-pump ang gas sa vehicle. It uses in the paper industry and it uses in chemical industry. So what are the parts of a pump? So as you can see in the image provided, that is an example of a pump and it is labeled by its different parts. We have housing or casing. We have the impeller, motor, the shaft or drive shaft, the volute, the bearing assembly, hub, and seal. Housing or casing. The housing or casing is the outer shell of the pump that protects most of the components from the outside elements. The casing of the pump should be of materials suitable to withstand the environmental conditions of the application. Example, submersible pump should be water and rust corrosion resistant. So obvious, ang housing casing dapat survive siya sa kung asa nimo siya ibutang na environment. Next is impeller. It is a rotating disc with a set of vanes coupled to a shaft. When the impeller rotates, it imparts energy to the fluid to induce flow. Flow characteristics of the pump vary widely based on the impeller design. Next is motor. The motor is the power source of the pump, drives the shaft. AC alternating current motors and direct current motors are the most common power sources of pumps. But internal combustion engines, or the ICEs, hydraulic power and steam power are other possibilities. So usually daw, ang motor, mamugay nag-power sa katong pump, katong mediator, it is usually an AC motors or DC motors. Pero pag sa mga ano, mga dagko nga mga pumps, hinala na siguro ka ng mga hydraulic power o mga steam power. Next is shaft. The shaft connects the impeller to the motor or engine that provides power for the pump. The shaft and its support arrangements must maintain alignment of the rotor within its running clearances and through the shaft seal. Volute. Volute is the inner casing that contains the impeller and collects, discharges, and sometimes recirculates the fluid being pumped. The materials used to construct the lining of the pump volute must be compatible with the handled media. Another is bearing. Bearing is a mechanical support, allows continuous rotation of the impeller, and is continuously lubricated. Makita gyapon sab nato ini sa mga motors, sa engine, mga bearing, para maka-provide siya ng continuous rotation. Siyempre na may mga bearings as you can see in the outer part of the circle. Next is hub. A hub is a device attached to the bearing assembly, which is the connecting point for the motor or engine. The seal. The seal protects the bearing from contaminated by the pump media. Some pump designs are sealless, meaning the pumping mechanism is completely contained within a pressurized volute chamber with static seals. So, kailangan nimo ng seals para secure ang imong pumps. Now we move on to the classification of pumps. There are two major types of classification of pumps. First is dynamic pumps. What is a dynamic pump? Dynamic pumps impart velocity and pressure to the fluid as it moves past or through the pump impeller and subsequently convert some of that velocity into additional pressure. It is also called kinetic pumps. Kinetic pumps are subdivided into two major groups, and they are centrifugal pumps and vertical pumps. This is the figure that is shown is the different subtypes of dynamic pumps, so centrifugal pumps. What is a centrifugal pump? A centrifugal pump is a rotating machine in which flow and pressure are generated dynamically. Centrifugal. The energy changes occur by virtue of two main parts of the pump, the impeller and the volute or casing. So, impeller, as we can see in the picture, the impeller and then the volute. The function of the casing is to collect the liquid discharge by the impeller and to convert some of the kinetic energy into pressure energy. So it's more on ang movement ng water is makaproduce pud ng pressure, murag i-convert niya sa gikan sa impeller. Centrifugal pumps are subdivided into several categories. So nakita nato to sa as we can see here in figure 2, we have three subtypes of centrifugal pumps. The first is the radial flow. Radial flow is the impeller discharges fluid at right angles to the shaft axis. In this centrifugal pump, the pressure is developed wholly by centrifugal force. The radial type pumps are used for the application of high head and low discharge. Radial flow pump is used for pumping a low or medium flow rate at a higher delivery head. They are typically used for lift, irrigation, and drainage of agricultural lands, sewage applications, or other applications. So from the word centrifugal, radial meaning circular path. It also uses application of high head and low discharge. So bali ang mechanics ng radial flow nga pump is dako ang iyang head pag enter sa water sa impeller, tapos high pressure, low discharge, meaning kusog ang pressure. Sa pakita nato diri sa right side sa sa photo, ang outlet is medyo gamay siya kaysa sa inlet sa suction. So that is the type of pump, high head and low discharge. Next is mixed flow. The mixed flow is the flow direction is partly axial and partly radial. So amo nga gitawag siya mix, kay mix siya sa duha ka type ng flow. Hence, as a result, the flow is diagonal. The mixed flow type pumps are used for the application of medium head and high discharge. In this centrifugal pump, in which pressure is developed partly by centrifugal force and partly by the lift of the vanes of the impeller on the liquid. So, sa diri is duha kibali kabuk ang dalawa. There are two kinds of pressure being developed. It's with the centrifugal force and then sa impeller ng mga vanes. So mixed flow. Next is the axial flow. Axial flow is the flow through impeller is parallel to shaft axis, low head and very high discharge. So it is the opposite of the radial flow. The axial flow type pumps are used for the application of medium high and high discharge. In this centrifugal pump, in which the pressure is developed by the propelling or lifting action of the vanes of the impeller on the liquid. So we have a series of nomenclature, specific speed NS 500 to 5,000, and it should be greater than 1.5. That is the radial flow pump. For the specific speed of 5,000 to 10,000, it should be less than 1.5. That's for the mixed flow pump. For the axial flow pump, the specific speed is 10,000 to 15,000. It should be equal to 1. So I guess this is ratio. The next subtype or major type of a dynamic pump is the vertical pump. What is a vertical pump? The vertical pump is also known as a cantilever pump. It uses a unique maintenance design and exclusive shaft. This pump has a maintained design and special shaft that allows the volume to fit in the pit when the bearing is outside the pit. It does not use a filled container to cover the shaft, but uses a throttle sleeve. A parts washer is the most popular use of this type of pump. So vertical pumps have different types that are given the following. The first is the horizontal pumps. The horizontal water pump has at least two impellers. This used for pumping service. All faces are in similar shelters and are mounted on similar axes. At least 8 additional steps can be mounted on a single horizontal shaft. Each step lifts roughly the same amount of head. The multi-stage water pump can be primed, double or single suction with the first impeller. So that is an example of a horizontal pump. Next is the submersible pump. These are close-coupled pumps driven by submersible motors and designed to be installed underwater in damp wells. The motor mounts under the bowl assembly and directly connects to the rotor shaft of the pump. A submersible pump, also known as a septic tank, sewage and rainwater pumps. It has many applications including construction, municipal, industrial, local, household, commercial, and stormwater recycling services. So I think we can distinguish this example. This is a kanang kanang sa garden bitaw, water sprinkler man na siya tawag. So rainwater pumps kakita naman ta. So di ba murag kusog ang pressure niya, so most certainly na siya pump. The next subtype of the vertical pump is the line shaft pump. The controller of this type of motor connects to the ejection head. The shaft system extends through the column to the drum assembly. In this way, the shaft transfers the torque to the rotor of the water pump. So now I am going to hand over to our next reporter, the second type of classification of pump.
So, hi, I'm Piolo Louis Arisada, reporting pumps. Second classification of pumps is the displacement pumps. Next slide. The positive displacement pumps. The moving element or piston, plunger, rotor, lobe, or gear displaces the liquid from the pump casing or the cylinder, and at the same time raises the pressure of the liquid. So displacement pump does not develop pressure. It only produces a flow of fluid. There are three types of positive displacement pumps. First is reciprocating pumps. Second is rotary pumps. Third is next. And reciprocating pumps. In these types of pumps, the plunger or pistons move downward and upward. During the suction stroke, the cylinder is filled with fresh liquid. After filling the cylinder, the inlet valve closes and discharges stroke starts. During the discharge stroke, the outlet opens and pressurized liquid discharges from the outlet valve. The inlet and the outlet sides have a check valve for preventing the backward flow of liquid. Reciprocating pumps have the advantage. It creates large pressure than a centrifugal pumps. Also, it is the best for high pressure requirements applications. But there is also a disadvantage. First is these pumps are not best for high flow applications because it produces a low flow rate. It has high initial cost because it is a large amount of components. So reciprocating pumps sa bigger components, so dagko ni siya nga equipments. Next slide. The reciprocating hydraulic pumps further divide into following three types. First is the plunger type pumps. The plunger pump has a crosshead operated by a cam-handled device. Its capacity adjusts by varying the pump speed or the stroke. The stroke changes through the setting of the eccentric pin. The advantage of plunger type pumps, it consumes low energy. Also, linear performs curve. And disadvantage of plunger type pumps, it delivers a pulsating flow of fluid, and it can handle only those fluids that have a low flow rate. Second type of reciprocating pumps is a diaphragm pumps. This type of pumps are versatile and can handle a large number of fluids, including dry food powders, wastewater, wastewater, additives, pharmaceuticals, and chemicals. The advantage of diaphragm pumps is that it does not require any packing or seals. That is, it uses in application that do not require leakings. It designs for pumping slurries and liquids. So you can see diaphragm pumps, diaphragm pumps. From the word diaphragm, tiyan, dako gina siya. Dago. So next is piston pumps. The piston pump is a simple and powerful device. It has a piston, a chamber, casing, and a series of control units. The piston of this pump gets power of an electric motor via shaft. The piston connects to the shaft, and the rotating part is also linked with the shaft. As the rotating part turns, it turns that the shaft and the piston turn to pull it back. These pumps have contracting and expanding cavities that move in a reciprocating motion rather than a circular or rotary motion. Alternately, drawing the fluid in and then pushing it under pressure. The periphery of the piston usually has one or more O-rings to seal against the cylinder as the piston moves, and check valves on either side of the pumping chamber stop fluid flowing in the wrong directions. Next. The next positive displacement pump is a rotary pump. The rotary pump's rotor rotates or replaces the fluid by orbiting the rotary movement. The rotary pump mechanism consists of housing vane, cams, runner, inlet, and outlet ports. These components of the rotary pump helps to transfer fluid. So you can see from the right side drawing, these are casing, junction, runner, vane, and discharge. These are the self-primary pumps and offer an almost consistent delivery rate, regardless of the pressure. They are manufactured with a minimum clearance between the stationary and rotating components for minimizing the leakings from the pressure side to the suction side. These pumps work at low speed to sustain this clearance. The rotary pumps has the following further types. First is the rotary lobe. The rotor of this type of a pump does not touch the housing during its working. The liquid sucks in from the suction valve to the cavity between the chamber wall and lobes. Due to the meshing of the rotors, the liquid can't escape between them. Therefore, liquid exits from the nozzle along the rotation direction of the outer lobe. These have various characteristics, such as reliability, hygienic quality, rust resistance, and excellent efficiency. Next type of rotary pump is screw pumps. It is a singular kind of positive displacement rotary pump in which the liquid flow through the pump elements is axial. It is a non-clog, large capacity atmospheric pressure device that can pump various waste and solids from the original raw sewage. However, these have practical limitations about pumping the head. It uses two screw, driver and driven screw, for pressuring the fluid. These screws are meshed with each other. Next type is progressive cavity pumps. These type of pumps are specially designed for the transportation of viscous and abrasive liquid from high content of air, fibers, and solids. The rigid steel screw rotor spins and rotates in elastomotor stator. They are best suitable for multi-phase, nasty, tough, liquid with solid and gas in suspension at comparatively medium temperatures. These are best for shear sensitive liquid. These pumps can control both high and low viscosity material such as vegetables and fruit. They designed for a volumetric flow rate that is proportionally to the turning rate of the pump impeller. The advantage of progressive cavity pump is the pump are good for solid and other complex fluid. It has a self-priming capability. It has a quiet operation. And disadvantage of this is it has high maintenance cost. The alignment of the shaft is very hard to maintain, and dry running even a few seconds may damage the stator. And the last positive displacement pumps is pneumatic pump. A pneumatic pump is a positive displacement pump. They use for the applications such as water treatment, food, and chemical companies. This pump provides a stable flow of mixing and measuring, and it is also the capacity of pumping various liquids such as toothpaste or multiple chemicals. And these pumps pressure air uses to move the fluid. In the pneumatic ejector, pressurized air released from the delivery pressure vessel to outlet line by gravity through a sequence of surges via check valves. Next is the installation procedure of pump. The following are the procedure installing a centrifugal pump, but some of the procedure are the procedure in the other pumps. First is foundation. The foundation of the centrifugal pump should be substantially hard enough in order to support the pump and rest of installed industrial unit. Bolts for foundation should be of the proper size and embedded into concrete. A pipe sleeve should be larger than the bolt, which would allow for final positioning of the bolts. Next is mounting. The pump base must be leveled in such a way that the pump shaft is a vertical alignment. The pump suction as well as discharge flanges should be in a vertical and horizontal plane respectively. And the third is field alignment. Enough spacing needs to be kept between these forces of coupling hubs so that they do not strike each other when the driver rotor is moved towards the pump. In order to check the alignment, tools such as straight edge and taper gauge must be used. And number 4 is piping. The suction and the discharge pipe should be supported independently with the help of pipe hangers and support blocks. This will prevent strain in the centrifugal pump joint and casing. The pipe alignment needs to be checked before the connection is made. The piping practices should be as per the manual or SOP, the centrifugal pump, as it may directly affect the efficiency and power consumption your pump. Next is wiring. The centrifugal pump wiring needs to be adequate size to prevent voltage drop. It should be noted not to start centrifugal pump until it be filled with liquid. Rotation. The rotation of the centrifugal pump is indicated on the pump casing. The correct rotation needs to be established before assembling the coupling and base mounted units. Number 7, ground motor. Connect to the ground wire to the approved ground and then connect to the provided terminal. Number 8, primary flooded suction. Open the air vent valve, the plug and centrifugal pump casing to open the gate valve of the suction line. The suction line and the pump should be filled slowly with the liquid until steady flow is observed flowing from the air vent. It highly recommended opening the air vent valve to ensure all air has been removed from the casing. Second, the last is starting the centrifugal pump. In order to start the centrifugal pump, the gate valve in the discharge line should be closed and opened gradually so that the motor approaches full speed. Last is servicing. Periodical maintenance of the centrifugal pump is important to keep it problem-free and in good condition. Then the installation procedure, the installation standard of pump. ANSI pump, or the American, I don't know what the pumps, ASME B73.1 standard chemical or industrial process pumps. ANSI pumps are a type of single stage and suction centrifugal pump. This type is designed to the ASME B73.1 standard, and each size of this type of pump has identical envelope dimensions for all manufacturers. These pumps are broken down in size into 3 main groups. Group 1 covers pump sizes 1.5 times 1 to 6 to 3.0 times 1.5 to 8. Group 2 includes pump sizes 3 times 2 to 8 to 6 by 4 to 13. And the largest size are covered by Group 3, which are from 6 by 4 to 16 to 10 by 8 to 17. These dimensional standards among manufacturers for each size of pump is unique with the ANSI chemical pump, and it allows the users to switch brands without affecting piping location. Motor attachment, coupling, and bed plate dimensions. This type comes in a wide range of material depending on the application. In addition to the chemical industry, the ANS pump is also used in refineries, paper mills, ethanol production, and many other process plant environments. Then, the design procedure of the pump selection. With the following information, we can able to make a basic pump selection. First is the liquid name. Knowing that the liquid that you are pumping in a vital as it allows us to ensure that we offer pump construction from compatible material, thus avoiding potential corrosion and abrasion issues. Avoid taya. What is chemical makeup? Are there any solid present? If so, what is the maximum particle size and concentration? These are the questions that you may made in knowing the liquid name. Next is flow rate. This will determine the size of pump required. Higher flow rate requires a larger pump. Pressure. The pressure at the inlet and the outlet of the pump will determine the type, often the size of pump required. Knowing that the pressure you are pumping against allows us to select the most suitable pump technology. If you are unsure if your differential pressure, we can help to calculate it. Wow. Next is viscosity. There are many units of measurements of viscosity. However, we tend to work in centopos or CP or syntox CST. Viscosity is a measure of a liquid's resistance to deformation caused by stress, or more plainly, the thickness of a liquid. Viscosity is typically higher for thicker liquids. For example, water has viscosity of 1 cp at 20 degrees Celsius, whereas honey has a viscosity of approximately 10,000 cp. Viscosity affects the type of the size of the pump required. With high viscosity usually require positive displacement unit running at a low speed rather than centrifugal pump solutions. Density. The density of the specific gravity of the pumping liquid at operating temperature will affect how much power required to achieve the required duty. This in turn will help us size suitable drive or motor to operate the pump without problem. Last is temperature. This can affect the material or construction for the pump and the type of pump offered. Last slide is the source references. Now, thank you.